So right now you're doing your bell work, and this lesson is about 8-5, adding and subtracting rational expressions. The objective is just to add and subtract rational expressions. So we're going to prepare for this lesson by doing a little bit of fraction math, and this will help remind you of the skills necessary to work this lesson. So if you will, pick maybe 65 and work on that one right now. Thank you. And let me unfreeze the board here. Alright, so if you will work through this one now. Oh, you don't need this. Thank you. Okay, so do those real quick. Do number 65, which is 2/15 plus 3/25. I'm going to pause the video. Okay, so take a moment and work this. And if you can't see it very well, let me extend this. It's 2/15 plus 3/25. Okay, so what do we do when we add denominators? What needs to take place before I can perform this operation? We have to have like what? What has to be the same? The denominator. Very good. Okay, so my denominators need to be the same. So in order to do that, I have to find multiples of each denominator here and find the least common denominator. Excuse me. So let's start with the 15. So what are multiples of 15? We have 15, and then 15 times 2 is 30. 15 times 3 is 45. 15 times 4 is 60. And 15 times 5 is 75. I'm going to stop there, and I'm going to come over on the other side and work on 25. So 25 times 1 is 25. 25 times 2 is 50. And 25 times 3 is 75. I see right now I've got a common number, but you got to make sure it's the smallest number that they share. Okay, so let's look through the list methodically here. So there's a 15. They do not share a 15, so that's out. They don't share a 25, so that's out. They don't share a 30. They don't share a 45. There's not a 50 in each one of these, nor 60. So the smallest number that both of these denominators share is 75. So that's our number. Now we have to convert each fraction to what? To 75ths. Okay? So let me delete this stuff. Oh my goodness. That's a lot of it. Alright, so what we're going to do is convert both of these to 75ths. So for the 15, what do I need to multiply 15 by to get 75? It was 5. And if I multiply the denominator by 5, I have to multiply the numerator by 5. Because what have I done to this fraction of 2/15? I've just really multiplied it by 1. But I'm making 1 fit our needs, because when we multiply this together, you're going to get 2 times 5, which is 10, and 5 times 15, 75, which is what we're shooting for. We're trying to get this common denominator. Now let's convert the other side. Let's convert our 3/25. Well, what do we have to multiply 25 by to get 75? 3. So if I multiply the denominator, I also have to multiply the numerator, because I'm just multiplying this fraction by 1, but we're making 1 fit our needs. So now I've converted the first number, 2/15, to 10/75. Now I'm going to convert my 3/25. So that's going to become 3 times 3 is 9, and 25 times 3 is 75. So the second number converts to 9/75. And you keep your sign, add or subtract. This was an add. So we're going to add these two numbers. Now that their denominator is the same, we can perform this operation, whether it's add or subtract. Okay, so you keep your denominator and you perform the add to the numerators. So it's going to be 10 plus 9, which is 19. So our answer is 19/75. Any questions on that? If you will get your yellow calculators, let's do this together on our calculator. And I'm going to show you how to do fraction math on your calculator if you haven't done it yet. So again, I'm going to set this aside. Let's do this number 2 because we already know what the answer is supposed to do. What it's supposed to be, excuse me. So we're going to add 2/15 plus 3/25. It's a 5. All right, so turn on your calculator and hit clear. Now, if you notice on your calculator, at the very top left button, that's that green second function. Go over one row to the right and down to the third button down. And it looks like this, N over D. What do you think that N and D stand for? Very good, numerator and denominator. So press that button, N over D, and what you're going to get is a blinky box on the top and a hollow box on the bottom. That's what you should see on your screen. The blinky box, it's blinking because that's where the cursor is sitting. It's waiting for us to input a number. So let's input that first number of 2. And instead of enter, you've got this cursor button that's oval over on the right side. I want you to push the down arrow. Okay, so use your cursor. We call this our cursor. Cursor down, and it'll take you into the denominator box. Now it's the blinky box. Now type in 15. And instead of pressing enter, press your right cursor. So the right side of your cursor. All right. Now we've got 2/15. Is there anybody who didn't get that? If you didn't get it, wave your calculator at me. All right, very good. Now do your mathematical operation plus, and now hit the N over D button again, and now type in 3/25, just like you did before. 3, down cursor, 25, and right arrow or right cursor. And when you're out of that second function, press enter. And over on the right hand side, it should very nicely have your answer written out as 19/75. Is there anybody who didn't get that on their calculator? Okay, now I'm going to show you how to get an alternate answer. What if all of your multiple choice answers were in fraction form? Okay, so you can get an alternate answer and get the fraction form of this by using your alternate answer button. The alternate answer is on the bottom right hand corner. You've got the enter button, and then the button above that is 2 arrows that look like this. Press that button right there that have the 2 arrows. That's your alternate answer. When you press that, you should get 0.253333 repeating 3's. Okay, did everybody get that? Anybody need help? Okay, press the alternate answer button one more time. Oh, now we're back to 19/75. Press it again. Now you're back to decimal. So it's a toggle between your answer types, okay? It toggles from the decimal to the fraction, to the decimal to the fraction, okay? Any questions about how to do the fraction math on here? Okay. So now you know. Just for grins, why don't you work number 66 on your calculators real quick, and I'll write it bigger. It's 7/24 minus 5/36. I'll do it too. I hear you guys clicking those so fast. I get so paranoid on calculators. Okay, I got this. Let me know if I'm right or wrong. Did you get this, or did you get something different? Did everybody get that? Alrighty. Because you know me and calculators, we don't get along all the time. But I'm slowly getting swayed. Okay, any questions on how to do the fraction math by our big beautiful brains or by calculator? Alright. Oh, pass up your lessons from yesterday, the 8.3 and 8.4. So we're going to do rational expressions and do adding and subtracting rational expressions. And when you go back to think about these last few days, what is a rational expression? It's like a big long polynomial over another big long polynomial, or it could be a short polynomial, could be a monomial, right? But rational expressions, we're going to have stuff on top and bottom, numerator and denominator. So when we do this and then we start adding and subtracting these rational expressions, okay, the multiply and divide's easy because we just multiply, and then for divide we flip the second term and multiply. That one's easy. But when it comes to add or subtract, we've got a lot of extra work to do. Okay, when we add or subtract, we have to have like denominators. And that's what this lesson's about, is in a big long polynomial, how do you get a common denominator? Okay, and let's start off by just looking at our first problem. Now, the first step to add or subtract rational expressions is you've got to find a least common multiple. A least common multiple. Okay, so they're asking us, we're not adding or subtracting yet, we're just finding least common multiples of things. So they're getting us ready to add or subtract. So the first step is just finding that least common multiple so we can get a common denominator on both fractions, okay? Or rational expressions, I should say. So what we have to do is start by writing each term down. So 12, that number's so dark. Yeah. We're going to have 12x squared y times the trinomial x squared plus 2x plus 1, and the expression 18xy cubed times the trinomial x squared plus 5x plus 4. So write those down. The next thing we want to do is prime factorization. Okay, so what we're going to do is factor these out all the way down to the most simplest terms. Okay, so let's look at the first one. So we can rewrite 12x squared y. Let me make this bigger. 12x squared y. That portion of it, we can rewrite 12x squared y as, well, 12 is 4 times 3. But we're still not done with 4. 4 is not prime. 4 is 2 times 2. So we can rewrite 12 as 2 times 2 times 3. All of those are prime numbers, right? And then x squared is just x times y. Now let's put all of these back in terms of powers. So here I've got a 2 squared times 3 times x squared times y. Okay, so that's our first step. 2 squared times 3 times x squared times y. So let me go back, and that's exactly what they did right here. They just left out all that explaining I just did. So they went from there to there. And really this is a pre-algebra type thing. This isn't even algebra 2. The only algebra 2 part of it is we're doing this to rational expressions. But this part should be, it should be coming back to you. Now look at the second part of that first term. It was that trinomial, x squared plus 2x plus 1. Okay, remember x squared plus 2x plus 1. Remember when we had an a plus b squared in algebra 1? We said that's equal to a squared plus 2 times a times b plus b squared. Remember that rule? And then in algebra 2, we looked at things and decided, does it fit this rule? Well, when you look at this, you recognize that is a binomial squared. Because what is the square root of this? X. What's the square root of 1? 1. Multiply x and 1 together, you get 1x. Now double it. See, that's your 2 times a times b. That's going to be 2x. So this fits our equation perfectly. So we know that this is a binomial squared. It's x plus 1 squared. So rewrite it, and that's what they did right there. Okay, so that's your first term, just using a few little algebra 1 tricks. All right, now are there any questions on that one? Now let's do the same thing to the next one. 18xy cubed times, well, this one, there's no formula, except we've just got to do the magic x, right? What, 2 factors of 4 add it to be 5? Well, 4 and 1. So we can rewrite this trinomial as x plus 4 times x plus 1. And then we've got the 18xy cubed. So let's go to the next page again. 18xy cubed. Well, 18, prime factorization, 2 times 9. 9 is not prime. 9 is 3 times 3. Now everything here is prime. So we've got 2 times 3 squared. So 18 is 2 times 3 squared. And I'm just going to leave these back in the powers, and you'll see why in a minute, times x times y cubed. All right? Everybody see that one? So 2 times 3 squared times x times y cubed. So now, there it is right there. And now, the trinomial we're going to rewrite as that product factor of those two binomials, x plus 1 times x plus 4. Now we factored everything out. That's all we did here is we just did algebra 1 factoring on these two terms. Now the algebra 2 part comes in here. Now what we're going to do to find the least common multiple of all these things, we are going to take for each term, so here's a 2, you're going to take the one with the highest power. So what has the higher power, 2 or 2 squared? Say it. Which one has the higher power, 2 or 2 squared? Yes, so we're going to take 2 squared. So I'll highlight these with the dot as we get them. So 2 squared, now that one's done. Now go to the next term. We've got a 3 and a 3 squared. What's the higher power? 3 squared. There it goes, 3 squared. Write that down. Now we've got, I can't read it, x squared and x. So what's our higher power? X or x squared? X squared. Very good. All right, so now the x's are done. Now look at your y's. You've got y and y cubed. The higher power is y cubed. I can't wait to get the rest of my incentives from Pencil Box, and I'm going to be passing out goodies to you guys all the time. Oh yeah. Did you say amen? Oh man. I used to like, amen. Church. All right. So anyway, we've got all of those. Now let's look at the binomials. And actually this is really cluttered, so let me back off. Okay, so we've done all of these. Now let's look at all of our binomials. Look at the same binomials. I've got an x plus 1 squared on the top and an x plus 1 on the bottom. So which one of those has the highest power? The x plus 1 squared. So that's the one we're going to write down. So do you see, for every term, we're writing down the term that has the highest power. And lastly, we've got this lonely little cold and shaking, sad and lonely little x plus 4. He has nobody to share anything with. So we just got to write it down. Okay? That's the best we have, so that's what goes. That's the highest power is itself, because there's nothing to compare against. So he goes. All right? And now, what if I just told you that's your answer? That's your least common multiple. Now, on a test and on some answer keys, they'll do the squares back on the actual numbers. Like they might write that as, let's see, that's going to be a 4, 3 squared is 9. They might go ahead and write 36x squared y cubed. But so far, I haven't seen that. Here, oh yeah, oh, there they did it. So they're saying either way is acceptable. So on a test, before you go to the work of simplifying it again, just look and see what your choices are. You know, maybe it's going to be in that simplest thing and you don't have to put them all back together. Okay? Any questions over that? You know, going through one of these takes a lot the first time, but you're going to find that they're real easy. Let's look at number 1 on 8-5. And I'm going to write it down here. 4x squared minus 36 and 6x squared plus 36x plus 54 . Not coming out, huh? I saw that. These things don't rip. Some days they rip, some days they got a mind of their own. I've got kids that said, do you have a piece of tape, Miss Downey? And I'll give them, they're like, no, that's not big enough. And they're papers in 2 pieces. It's like, just turn it in. I got it. All right. So let's work this one. So we can factor these any way we want, right? It's up to us to decide how we want to do it. So when I look at this first term, this 4x squared minus 36, actually they've done it for us. So let's just talk through what they did. Because they always give you that jump start in each problem set. They give you what I call like a little push start or a jump start. So what they've done is they first factored out the 4 out of both of these terms. So when you do, you get a 4, what's left over? X squared minus 9, right? Because if we reverse this, what do we get? 4x squared minus 36. Okay, everybody with me there? That's an algebra 1 thing. All right, next, we're good there. Now, let's work this one down, and then I'll go over and work the other one down. All right, so let's just continue down with this one. So now, let's rewrite 4, because 4 is not prime. 4 is what? 2 squared. Now, 2 is prime, so we're good. All right? Now, what do we know about this guy? Algebra 1. How about the difference of 2 squares? Because x squared is just x squared. And 9 is 3 squared. So this is the difference of 2 squares. And we have a rule from Algebra 1, and we did it again for a semester. When you have a difference of 2 squares, that factors out to, if that's a and b, a squared minus b squared, right? So it's going to be a times b, which is x plus 3, times a minus b, x minus 3. And that was just one of those things you should be recognizing at this point and remembering. Difference of two squares. It will save you so much work if you just start remembering. Alright, now we can rewrite x. Oh no, these are all different because that's an x plus 3 and that's an x minus 3. I started to say we can square those, but you can't because the signs are different. Alright, so we're done there for right now. And actually that's where the book left off, on this side. Okay, now let's look at the other side. And again, what can we factor out of all three of these terms? A 6. 6 is in common with all of these, so let's factor it out. And what's left over is x squared plus 6x plus 9. And now we could see this as there's your a squared plus 2ab plus b squared, right? And so that is x, and that's a 3. So that's going to be x plus 3 squared. Okay, and don't forget the 6, and we need to rewrite 6 as 2 times 3. And if you forgot about this rule here, I'll delete it right there. The rule went like this: a plus b squared equal a squared plus 2ab plus b squared. So if you can recognize something in this pattern where that's a square of something, that's a perfect square of something, now multiply those square roots together and double it. Does it match that? Then you've got a plus b squared. Okay, and that's just practice, guys, just to keep remembering those little rules like that. Well, I deleted mine. There it is. Alright, so now we've got our next step is to take the highest power of each thing, right? If you've got it down to most simple terms, which we do on each side. Now, let's look at we're going to look at both of these, and we're going to take the highest power of each term. So, let me get a highlighter. Right, so for our 2's, I've got a 2 squared and a 2. The higher power is 2 squared, so we're going to take that. We only have 1 3, so he's got to go. So he's there. Next, I've got an x plus 3 and an x plus 3 squared. Well, the x plus 3 squared is the highest power, so that's what we're taking. Okay. And then we're left with the lonely little x minus 3. And so this is your answer, or you could put these back together. That's going to be a 4 times 3, which is 12. So you could have 12 times x plus 3 squared times x minus 3, or I prefer myself to have the 2 squared times 3. I like to leave it in the factored form. But remember, just look at your answers before you start changing and simplifying. Any questions on that? Sorry. All right. On number 2, I wrote something underneath it last year. I wrote this. Too easy. Under number 2. So let's see why it's so stinking easy, okay? It's like probably giving myself that note, like, don't even assign it, because I don't know if you'll really learn from it. So let's look at what they gave us. x minus 2 times x plus 3. And then they give us and 10 times x plus 3 squared. Well, the only thing we can factor out is 10, which is just 5 times 2. But look, there's no other coefficients to share anywhere. So it's just starting, we've got 5 times 2, or 2 times 5, so that one's done. Now let's see, let's go to x minus 2. I don't have another one of those, so he goes x minus 2. And I've got an x plus 3 and an x plus 3 squared. So my squared goes the highest power. Okay? And that's your answer. Like I said, too stinking easy. There was no factoring. That was not a challenge. So your first problem set is done. Alright, does anyone have any questions on those? So what we've done basically is we've learned how to find a common denominator. And that's the process you use to get this and this. Okay, one of the ways you can do it. Okay. So this would be that common denominator for both numbers. But now we're going to learn, what do you do with it once you get it? How do you convert the top numbers once you get this? Okay. So oh my goodness. Alright, so for the next problem set, it says the least common multiple of denominators of two rational expressions is also least common denominator of the rational expressions. So we do the same thing for our rational expressions. We have to have a least common denominator. And we're going to use this to add or subtract our rational expressions. Okay? Okay, so for problem 2, I've asked you to observe this expression. It's an addition problem of two rational expressions, and ask you to think about the restrictions on the variable. So what can x never be for this one? 1. So we know that x cannot equal 1. Now how about over here? Well, it makes it easier if we can factor that first, and then we can quickly state our restrictions. So what is this trinomial factor to? Guys, you should actually be at the point where you're just seeing this, that you don't need this x. What, 2 factors of 2 add up to be -3? Well, -2 and -1. When you multiply them, you get a +2. When you add them, you get a -3. So that's the x minus 2 times x minus 1. So now, it worries me because it's an Algebra 1 thing that I'm not getting like just a barrage of answers from you guys on this. Maybe my incentive tub will help you guys when I get those next week. So now what can x not be from the second term? It can't be a 2. Whoops. I'll write with an eraser. And we already have 1. So we know it's just 2 and 1. It cannot equal 2. It cannot equal 1. So we've got our exceptions there, okay? Now let's work on the problem. So I already factored that bottom term, right? And here it is factored right here. Right, so there's our first, right there, and then they factored this one down there. Everybody see that? So that's the first step, is they factored both denominators. Now what we want to do, we've got to get a common denominator. So if I have an x minus 1, and then over here I've got x minus 1 times x minus 2, well, what do I need to multiply? Obviously this is the smaller one, he's half like the other because he's got the x minus 1. So what is this first little term missing to make him the same as this one? What do we need to multiply this by to make it the same? X minus 2. Very good. Very good. So that's what we're going to do to this guy, because we need to get the denominators the same. We need to multiply this by this x minus 2. Right? But if we do it to the bottom, we have to do it to the top, right? Because in essence, all we're doing to this guy, x over x minus 1, we're just going to multiply it by 1. But we're going to make 1 fit our needs. If we multiply it by 1, it's still itself, right? It's just going to look a little different. And we need this bottom term to be x minus 2. So at the top, see, we just multiplied this guy times 1. But the one that we chose to represent by 1 is going to make it fit our needs of creating a common denominator. Do you see that? So that's how you convert this guy to have the same denominator and to be able to add those together nice and easy. So we're going to multiply it by x minus 2 over x minus 2. And that's what they do in this next line right here. Everybody with me? All right, now this next one is just straight copy down, same thing. All right, now we've got to combine these. So we've got to multiply. So this top numerator is going to be x squared minus 2x. That's our next step. There it is. X squared minus 2x right there. And the denominator is the same. And this, again, is just a straight copy down. So the only thing we did is we multiplied these together to get that. All right, so the next step now is going to be to add these top, all of our numerators together with our like terms. So you're going to have x squared minus 2x plus 2x minus 1. All right, and then the minus 2x plus 2x, well, that goes to 0. So I'm left with x squared minus 1. Now, I realize right away, because that's the simplest form of that difference of two squares, so I know that's going to be an x plus 1 times x minus 1. So rewrite your difference of two squares as x plus 1 times x minus 1. And then you can cancel out common terms. So the x minus 1 cancels out, and I'm left with x plus 1 over x minus 2. And that's my answer. And then you state your restrictions. X cannot equal 1, or x cannot equal 2. And that's it. Let's work our first one in our workbook. Okay. You're so quiet. And guys, the addition and the subtraction, the only hint I would give you on the subtraction is before you do that final step of subtracting all these terms, I would write it like this. Let's see, this one right there, 2x plus 4, and this is the numerator part, minus, and I would put all of this in parentheses, x squared minus 2x. So you remember, oh, okay, I'm going to distribute a negative 1 to these terms, or flip everything inside and change it to add. Okay, because that can trip you up sometimes on the subtraction. Don't forget about that, because you're subtracting both of those things. All right, so let's look. Your homework over the weekend will be to work the first page, actually through 8. And 9, we're going to start with 9 on Tuesday with our bell work. But let's do the first problem together. Let's look at number 3. And they give us 6x minus 1 over x squared y plus 3y plus 2 over 2xy. So it shows our first steps. They factor everything out. There's nothing on top that we can do for the first term, but the second one, they're going to rewrite that as an x times y. And over here on the right, they're going to write that as a 2 times x times y. So they didn't change anything over there. All right, so what's your next step is to figure out what do these denominators have in common. Actually, just let me move this one out of the way. And move that up. X times y. All right, so what do they have in common here on the denominator? Well, they've got an x common, they've got a y common. What's left over? 2x, right? I'm looking at how I did this last year. Okay, so to get this one to look like this one, what do I need to multiply it by? A 2. And what is this one missing? An x. So for this one, we're going to multiply by 2 over 2, and this side we're going to multiply by an x over an x. Okay, now watch what happens. So we're going to get well, I'll just rewrite it first. 2 times 6x minus 1 over 2 times x times y. And we're going to add 3y plus 2 times x and x times 2 x y. Okay, so I just rewrote it a little better. Okay. Now let's distribute everything. So we've got over here, it's going to be a 12x minus 2 over 2, I'm going to go ahead and just call that x squared, 2x squared y. And over here, I'm going to have 3x y, because it's at y, 3y plus 2, it's going to be distribute the x there and distribute the x there. So 3xy plus 2x over, and now again, it's going to be a 2x squared y. Now we have common denominators. Okay. So now we can perform our math. So that is up, that looked like a square, but it's not. It's down there. Okay, so we've got 12x minus 2. I'm just going to combine them all. 12x minus 2 plus 3xy plus 2x all over 2x squared y. Now I'm going to combine all my like terms. On the numerator, I've got a 12x and a 2x. So those add up to be 14x. And then my next term would be 3xy minus 2 all over 2x squared y. Okay. Oh, I forgot our exclusions. So look at the original equation. What can x never be? And what can y never be? So when you look at these, what would turn this equation to 0 if x was 0 or y is 0? So x cannot equal 0, y cannot equal 0, because if we did, that would go to 0. And same thing over here, so it applies for both. So that's what you say at the end. There's my answer, and notice that x cannot equal 0 and y cannot equal 0. All right, so work 4, 5, 6, 7, and 8. I would say probably 5 and 6 are the most involved, and the rest of them are pretty quick. And you'll start with 9 on Monday, and then we'll do the back. Tuesday, and we'll do the back that day. Okay? Thank you. This concludes our video.